Welcome to Cambridge Chemistry channel with Sarvaseman. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will solve in this video I will solve paper 4 alternative to practical 507042 October November 2024. Let's start. A student does an experiment to make pure hydrated copper 2 sulfate crystals. The student makes aqueous copper 2 sulfate by reacting a dilute acid with the excess copper 2 oxide. Name the acid. This is dilute sulfuric acid. Figure 1.1 shows the apparatus the student uses to crystallize the copper 2 sulfate. Name the apparatus X. This is evaporating dish. Describe how the student decides when to stop heating the copper 2 sulfate when crystals start to form. Suggest why apparatus X is heated with water bath and not heated directly using the Bunsen flame. Number 1, water bath heats the solution more gently to prevent water of crystallization being removed and or prevent solid spitting out. Describe the final step needed to produce pure hydrated copper 2 sulfate. Dry the crystals at room temperature and pressure. Question number 2, student titrates 4 samples of aqueous sodium carbonate with 0.500 mole per dm cube dilute hydrochloric acid. In titration 1, the student arranges and fills a burette with 0.500 mole per dm cube of HCl. Add 25 centimeter cube of sodium carbonate to conical flask. Add methyl orange indicator to the conical flask. Add HCl from the burette while swirling the flask, adding drop by drop near the end point until the solution just changes color. The student repeats the titration 3 more times. Figure 2.1 shows the burette reading for 2 of the titration. So titration 1 and titration 2 is initial reading is 21.2 and final reading is 41.123 1 2 3 4 5 6 7 41.7 and titration 3 initial reading is 0.0, final reading is 19.9. .7 minus 21.2 is equal to 40.5 and this is 19.9 and this is 40.4 minus 20.3. This is 20.1. So the best titration is 19, 20.5, 19.9 and 20.1. Take the two best titrations result in table 2.1. Use the tick titration results in table 2.1. Calculate the average volume of HCl needed to neutralize 25 centimeter cube of the aqueous sodium carbonate. The volume by using these two, 19.9 plus 20.1 divided by 2, this is the mean volume, plus 19.9 is equal to divided by 2 equal to 20.0. Use your answer to calculate the number of moles of HCl in the average volume of HCl needed to neutralize 25 centimeter cube of aqueous sodium hydroxide. Calculate the number of moles of HCl. Is equal to concentration into volume in centimeter cube divided by 1000. The concentration of HCl is 0.500 multiplied by 20 divided by 1000. 0.500 into 20 is equal to 10 divided by 1000. This is 0.01. The equation for the reaction between HCl and sodium carbonate is: use your answer from D to calculate the concentration of the aqueous sodium carbonate. Give your answer to three significant figures: mole ratio, HCl ratio and A2CO3, 2:1. We have 0.01 multiplied by x. So this is divided by 2 is equal to 0.005. This is the mole of sodium carbonate. Now concentration is equal to mole over volume into 1000. Mole is 0.05 divided by volume of sodium carbonate is 25 into 1000 divided by 25 is equal to into 1000. So the answer is 0.2. The student is provided with 150 centimeter cube of aqueous sodium carbonate. Use your answer to E. Calculate the mass of sodium carbonate in 150 centimeter cube of this solution. This is so 1000 contains 0.2, so 150 centimeter cube containing x. So the mole of sodium carbonate is 0.03, MR of sodium carbonate is 106, so the mass is 3.18 gram. State why the conical flask is swirled while HCl is added to form burette. To mix the contents, state why the HCl is added to 0.2, ensure endpoint is not exceeded. Question number 3. A student investigates solution P and Q. Solution P is colorless and contains sodium ion. Describe how to do a flame test on solution P to confirm the identity of this cation. Dip wire into solution P, put the wire in blue flame of Bunsen burner, blue flame is converted into yellow flame. Solution P contains an anion composed of nitrogen and oxygen. Describe a test to identify the anion in solution P. Nitrogen and oxygen mean that it contains nitrate ion. So add sodium hydroxide, aqueous, plus aluminium foil, to solution P, and then warm the mixture. Gas is evolved, which turns damp red litmus paper blue. Identity of ion is nitrate ion, because it also shows that an anion composed of nitrogen and oxygen, so the anions contain nitrogen and oxygen, definitely will be nitrate ion. The test the student does on solution Q are shown in table 3.1. Some of the observations for these tests are also shown. Add drop of aqueous ammonia to solution Q until a change is seen. Green precipitate, then add excess ammonia, green precipitate insoluble. So this is iron 2. Add drop of aqueous sodium hydroxide to solution Q until a change is seen. Green precipitate, then add aqueous sodium hydroxide soluble in excess, giving a green solution. This is chromium. The test of chromium, it means chromium ion is confirmed. Add aqueous silver nitrate solution Q, white precipitate, means this is test of chloride ion. So if white precipitate is formed, then chloride ion is present. Add dilute nitric acid solution Q, then add aqueous barium nitrate. So the answer identify the cation in solution Q. If white precipitate of chloride ion is present, so it means sulfate ion is absent, no change. Identify the cation in solution Q using the observation from test 1 and 2, that is chromium ion. This is insoluble in ammonia. With ammonia, chromium ion is insoluble in excess. Test 3 is incomplete. Describe what else must be done in test 3 to ensure that the white precipitate observed leads to a valid conclusion about the anion in solution Q. Add dilute nitric acid. The student complete test 3 correctly. The observation remains the same. Identify an anion in solution Q, chloride ion. The ion identified in 3 is the only anion in solution Q. Describe the expected observation from test 4. No change because chloride ions are present. Solution Q is acidic. Describe the observation when solution Q is added to sodium carbonate. Is acidic. Sodium carbonate, effervescence of or fizzing of carbon dioxide. Question number 4. Mons metal is an alloy that contains zinc and copper. Zinc reacts with dilute sulfuric acid. Copper does not react with dilute sulfuric acid. Okay? An investigation to find the percentage biomass of zinc in a powder sample Mons metal which contain only zinc and copper. Your plan must include the use of common laboratory apparatus, Mons metal and dilute sulfuric acid. No other chemicals should be used. The apparatus needed weigh 2 gram of Mons metal on balance. Put in 100 centimeter cube beaker and add dilute sulfuric acid zinc react while copper does not react. Filter the solution to remove unreacted copper by using filter funnel and filter paper. Wash the residue which contain copper with distilled water to remove impurities. Dry the residue and weigh the unreacted copper. On balance. Repeat the experiment and take the average mass of copper, percentage of zinc is equal to mass of minus mass of copper divided by mass of metal into 100. This is beaker, funnel, filter paper, so this is all about of this paper. Please like the video and subscribe the channel.